Okay, so let's start where we were dealing with, and we studied KNN algorithm, and we'll continue in the same for implementation part. Okay, and in the same process, what we did, we wrote up, I think, a data set. There's a Big-mart data set. We understood what is the different columns available in the same and what was our output. Our output requirement was to predict the item outlet sales. Okay, we saw that. After, let me execute once again because I have to do everything fresh again because it has gone from the RAM this time. Come on. Okay, sorry. Import pandas as PD. NumPy is empty. Yeah, done. Let me come again. Let me read it. You're done. Let me check first 5 rows. Awesome. And this thing we have seen, it's a regression problem because our output is what? Continuous numeric output. Okay, that thing we have seen yesterday. No problem. Okay. Then we check the shape of our data frame. Okay. And we came across there are 11 columns are input variables, and one column your item output says is output variable, right? We check the data type of the corresponding column, and from the same we get some information that there are seen some missing values. Okay, because in all there are 8,523 rows, which has been confirmed by this, but in some of the columns the rows are 7060, okay, which is showing non-null. Okay, non-null values are 7060 and 6113 spatially in the same. So to understand that better, we check out for the missing values using the df.isNull, which gave us there are 1463 null values in the item weight and 2410 values in the item outlet size. And item weight is your continuous numeric value. If you see here, where is item outlet item weight? Okay, it's a continuous numeric output. So what method we choose? We choose the method of imputation. We will substitute it the value of this column, the missing values in this column by the mean of that column. So we did that here. Come here. Also, let me read it once again. This once again. Come on. Okay, and then what we did, we computed the mean of the same column. Okay, what is the mean value? And then we substituted the missing values by the mean values, right? And then we checked that in one column in which the missing values were there, now there are 0 missing values. Now we discuss about item outlet size, which was a text column, and whenever it's a text column, the computation should be done with what? Mode, means which thing is occurring most time. So we computed the mode of the column, and then we replace your missing values by the mode of the corresponding column, okay, which was a medium. So we saw that there are no missing values. Okay, that thing I think we have seen. Okay, what is that? Okay, let me remove this. So far, this thing has been done. Perfect. So one important requirement was that there should be no missing values. And luckily, or by the going through the data set, we identified that there were 2 columns which are having the missing values. The columns were item weight, which was a continuous numeric output. So we substituted those missing values by mean value in the item weight and by the mode value in the item outlet size. This thing we have done smartly, right? Now move ahead. Let's go look at the other columns. One other requirement, 2 primary requirements are there. 2 primary requirements. What are 2 primary requirements? One primary requirement is that there should be no missing values. Okay, that we have done. Missing values. Okay, so we have dealt with that. How to deal with the missing value? We discussed very much in detail yesterday. We can remove the rows which are having missing values. Okay, or we can remove the column which are having missing values. But in our case, the missing values are larger numbers. So instead of removing the values, we choose the method of imputation. Right? Imputation means substituting missing values by some other values. Okay. And second primary requirement should be there should be numeric. All the columns should be numeric, or no text column, or there should be no text. Okay. For that purpose, what we have to do? We have to do encoding. We have to do encoding, and 2 kinds of encoding we studied yesterday. Everyone, can anybody recall what was those? Everyone, can you recall how can we replace our text column with the numeric column? 2 methods we discussed. Hardik, Varun, you were there. Tell me.
Yes, sir.
No.
There were
I'm talking.
outlet and no, so not sorry,
No,
outlet, not
not
outlet.
missing values. I'm not talking about the missing values. I'm talking about we have text columns now. So there are 2 kind of text columns that you may encounter.
Yeah,
Remember,
hot encoding.
for what purpose? There were 2. One, hot encoding.
Ordinal
Yes,
data for
yes.
the ordinal data.
We may have nominal data, right? In which there will be no particular order, like your gender, with male and female. So you cannot say male have a more weightage or female have a more weightage. Like in such cases, what we go? We go with one hot encoding, one hot encoding. Okay. Second was what? You are having ordinal
Ordinal
data,
data.
right? Example, double XL. Okay. Your garment size are giving double XL, XL, L, medium, small. So they have a particular order available, right? This is the largest. This is smallest. This is little smaller. This is further smaller. This is further smaller. This is smallest. In such case, what we do? We do encoding, but how do we encoding? Remember, the higher weightage to the item which highest in the in hierarchy, if we talk about, right, which is highest in the hierarchy. So highest weightage will be given to the double XL, then XL, then L, then M and S. And how we do? S example, S will be assigned the number 1, then M will be assigned number 2, L will be assigned number 3, XL will be assigned the numeric weightage to be 4, and double XL will be assigned the numeric weightage to be 5. That we discussed yesterday in detail. We discussed how do we do nominal, deal with the nominal data, and how do we deal with the ordinal data. Very much in detail we saw that. With practical, we didn't implement it, but theoretically everything we saw. Okay. You can recall or not? Everyone tell me please. That is important, because other
Yes,
than
sir.
that you will not be able to do that anything. That is important, remember. So we'll do that. How will we do that? That's not a problem. Okay. Now come to the column. Let me read it here again. Df dot hat. Okay, and try to analyze every column. Okay, so that you can do corresponding substitution. So don't worry about the item weight, already numeric number is there. Okay, so this is item fat contained. Just go through the low fat, regular, let me check. Okay, how many distinct values are there? So how can we check the distinct values are there? What is the column name? Item underscore fat. Come on, take it. Yes, content dot value underscore counts. It will show me it has different options available: low fat, regular, LF, reg, again low fat. Okay, so if you see properly, everyone, there are LF which is available. LF also means low fat. Okay, reg also means regular, but somehow somebody has imputed the data such that by typing, he was very much lazy. So instead of typing complete regular, he has typed reg. Okay, somebody was even more lazy in typing low fat. He just typed what? LF. And same way, somebody was this, okay, it doesn't even bother what other people have entered. He entered everything in a small letter, because Python is case sensitive. So we are getting actually how many distinct values? 1, 2, 3, 4, 5. Can you observe, everyone? But in fact, actually values are only 2, low fat and regular. But somebody has done, this is what feature engineering is come into the picture right now. Okay, you have to analyze the data. Somebody has give you data in a manner, this is only low fat and regular, but somebody has entered LF, somebody has entered regular, somebody has entered low fat. So although this LF, this low fat, and this low fat are same, one and the same thing. Okay, this regular and this regular is the same thing. That is the biggest problem what you are facing right now. And remember, they do not have any weightage, means this is higher, this is more weightage, this is lower weightage. Okay, so they are nominal. But if we do that, remember how many distinct values we will get? 1, 2, 3, 4, 5. So unnecessary 5 columns will be created for us. But in fact, only 2 columns should be created. What is that? Low fat and regular, or LF or RAC, whatever you want to mention. Right? So we have to make, first of all, some sort of feature engineering. What is feature engineering? Please go through that and clean your data. Clean your data properly. What is your cleaning? Means instead of LF, decide one thing. We will keep only one thing. Decide, in fact, we will keep only one thing. Either the term wherever low fat is there, I will use LF, or instead of LF, I will use low fat. Whatever is there. Clear, everyone, what I'm saying? Please, that is important to understand.
Yes, sir.
Okay, that's important. So what we will do? We will do something. We will map this. How will I do that? I will say that make some changes in this particular column. Take this particular column and decide first of all. Okay, suppose I decided everything I will keep will be for low fat, I will keep just low fat. Okay, and for regular, I will just mention regular. Okay, so wherever LF is this, I will replace by low fat. Wherever this low fat is there, I will replace by this low fat. Okay, whatever you decided to mention. Okay, suppose this one, the top one, low and fat. This is your decision that you want to keep. Okay, similarly, second one you want to keep is second theme that is mentioned here, regular. This thing I want. So what I will do, I will use a method known as map method. Okay, I'm going to say df item dot fat content is equal to pick the column and make the changes here. What dot map. Dot map, very much similar method we studied in the list. Remember when we want to apply some function on every element of the list, same way we are using a map method here. Okay, so what I want to map here, in the map actually I will pass a dictionary here for mapping purpose. And what I will mention, remember, wherever there is lf, instead of lf I want what, low fat. Okay, then wherever there is small low fat, this is key, I want low fat. Okay, again, wherever there is lf, I want again low fat. Again, wherever there is reg, okay, I want regular. Okay, done. And let me close my dictionary. Everything done. Let me execute this. Done. And now let me check. df item dot test dot value underscore counts. Check everyone. I think we missed something. What happened? How come their value have been so much reduced? I think we made some error somewhere. Please check with me. I think we made some error somewhere.
Sir, in low fat, F was capital in there, and then we used small somewhere.
I think we made some error. We have to check that actually. That is important to check. Otherwise, everything will be lost. Just check. Where is LF? Okay, let me do one thing again. Where is that? Come on, come on, come on, come on. Let me come here. I have to do it again. Unnecessary. Because I've done some error there because that column has been impacted. Come on. Let me do one thing. Cell. Run all cells. Let me check. Let me check. Come on, come on, come on, come on. We should just mention that. Okay. This will create a problem. So let me hash. Let me hash. Okay, any other thing? Any other thing? Yes, this will create a problem. Hash, hash. Okay, and now let me go back again from here. Okay, let me run this. A cell run. Just 1 second. Run this and see. Run all below. Okay. I was just saying that, and the same thing happened 1 second. No issue. Cell run all below. Again, I did the mistake. Same problem again. Where the mistake is, LF is fine, LF is fine, LF is fine, LF is low fat, LF is low fat is low fat.
So only the columns that you have mapped are being considered. The rest, the original ones are being not considered here.
Just started observing, but actually I have to do that once again because otherwise the same. Actually, I was not planning to run this one, but unfortunately it ran once again. So let me do one thing. Let me do something so that this cell at this cell it should stop. Let me do remove this. Okay. Now fine. Now let me go back again. Again, what happened? Come on here. Yeah. Not this, not this. Come on, come on, come on. Yeah. Cell. Come on, yeah, this is what I wanted. So I've done that, and let me just check once again. Map done, done, done. Awesome. Now let me do one more thing. Put this one. What is this? Exactly low fat with low fat, and one more thing, regular with regular. Okay. I think it should be done by now. Now it is fine. Yeah. See everyone, now only two values are there. Can you observe, please? See, so everything, this thing as well as this thing has been combined into this one thing. Please see. And similarly, this 2889 and this 117 have been combined into one thing. Right? That's why always, whenever you receive the data, that's why I told you yesterday, remember, spend at least 5 to 6 hours in the data set, just understanding what is my data. Understand you until you understand your data properly, you will not be able to build a machine learning model. If you give this data set to a beginner, honestly, he will directly take it and convert it into the text column. But that will give, see how many columns it will create: 1, 2, 3, 4, 5 columns. But actually, you need only 2 columns: low fat and regular. Clear, everyone? Please tell me. Right? So we just mapped what will be replaced by what. As simple as that. Clear? Please tell me.
Yes, sir.
Okay. So this thing has been done. Now move ahead. Okay. Fine. Let me come to the item type. Okay. Let's check. Dairy, soft drinks, meat, fruits, and vegetable households. Okay. I don't think so. There is any numeric weightage. Is there any numeric weightage for the dairy, soft drink, or meat? No, nothing at all. For non-vegetarian, meat is at the top priority. For vegetarians, actually, dairy products are dairy and fruits and vegetables are their top priority. So there is, these are what nominal variables? These are nominal variables, right? But let me check how many distinct values are there. So DF, what is the column name? Item type. Let me just check. Come on here. Put. Come on. Yes. Let me directly type. If it is not accepting, item underscore type dot value underscore counts. Okay. We have to also
60.
verify. We have to just check once more. Means here also things should not be repeated. That is also important, right? Unnecessary, they will occupy our space. So fruits and vegetables, fine. Snacks foods, household, frozen foods, dairy, canned foods, baking foods, health and hygiene, soft drinks, meat, breads, hard drinks, others, starchy foods, breakfast food, and seafood. Fine. I think there is no repetition, if I'm correct. What I can see, everyone. Can you see? Is there any repetition? I don't think so. Fruits and vegetables, snack foods, household, frozen
No
foods.
repetition.
Right, fine. This column is perfect for us. No problem. Now let me go to the third column. This is outlet identifier. Already fine. Outlet number have been given 49, 48, something. These are just identification number. Okay. Let me check. Are they unique or there is something special for the same? That is important because how many rows are there? There are 8,000 something rows are there, right? In our data set. I think we just check the shape. Where is the shape? Come on. Come on, come on, come on. Where is the shape? Yeah, 8,523, right? So if we have 8,523 unique values, that means it is unique for every row. Okay, if that is the case, there is no point in taking this particular column. Remember, we discussed that if your any particular column, a value is changing for every row, okay, then this value will never help you out in prediction some pattern because it's changing for every row. Getting my point, everyone? If some value is there, then in next row it is changing, in next row it is again changing, in next row it is again changing, next row again changing. So in everywhere, if it is changing again and again and again and again and again and again, will you ever find out any pattern, everyone? Right? What is the purpose of the machine learning algorithm? Simple. Find out the pattern among the data. means find out a relationship between output variable and the input variable. But when your input variable is changing again and again, again and again, for every row it is changing, it is never going to help you out in prediction. Okay, so if something is unique in every row, never pick that column. But from this directly, without even doing that, I can see here that this 49 is repeating. Can you see here, everyone? Can you observe? So it is not unique. 100% it is not unique, but we can verify, no problem. Okay, so what we can type, what is the column name? Outlets, outlet identifier. Fine, let me pick it up and let's verify. Same thing, df outlet identifier dot n unique. Okay, 10 unique values are there. Fine, no problem. Okay, we don't have if we would have 8,523 unique values, then of course we can drop that column. That column is not helpful for us, but it is unique, so we have to take into the consideration. Clear, everyone, what I'm saying? Please tell me.
Yes, sir, clear.
Okay, remember that is not unique, so it is means it has some sense available, so don't drop it. Okay, and also they have given some identification, so we can't decide what is the weightage of the same. We can't comment about the same. Okay, now this is outlet size. This is clear, everyone. See outlet size. What is that? How many values are there? Let me verify.
Just 3 values.
See, I think we have seen that, if I'm correct, right? Outlet size dot suppose value underscore counts, or we can say from the unique only. No problem. We have 3 values: medium, high, and small. Perfect. So can you tell me, everyone, this is a nominal data or this is the ordinal data?
This is ordinal data, sir.
Yes, this is ordinal, right? So there is an order clearly mentioned: high, medium, small, right? So for that purpose, we will not use one hot encoding. Okay, we will give highest weightage to the which is highest in the hierarchy, which is highest, high. So it will give more numeric weightage. Then smaller numeric weightage to medium, even a smaller numeric weightage to small. Okay, we will see that. Don't worry. But we are identifying what to deal with what kind of column. That is very important. Okay, now move ahead. Okay, now outlook location type tier 1, 2, and 3. This is actually information which is non-known to us. Okay, so I can't comment about how it is, but it is clear to us. But this about this tier 1, 2, 3, something which is mentioned. Let me check how many distinct values are there in the same. Again, df outlet, I think location type, if I'm correct, it is the same dot unique. Tier 1 and 2 and 3. So, okay, actually, until we know, that's why I say yesterday also, your business knowledge is very much required. Whichever domain you are working, if you are working in the same stores department, you may have idea, okay, what tier 1 means, what tier 2 means, what tier 3 means. Is there any numeric weightage of the same? Accordingly, you can decide whether I have to do, we have to consider it as a nominal text or the ordinal text. Okay, so we don't have any idea. It's a tier 1, tier 2, tier 3. What does it mean? So it entirely depends upon us what we want to be. If we don't know, of course we don't know, then we can't comment upon. Okay, that tier 1 has a more numeric weightage, or tier 3 has a more numeric weightage, or tier 2 has a more numeric weightage. So for simplicity, because we don't know, so we can say that we'll consider it. And whenever you are creating something, you mention that in your reports. Okay, consider it as nominal. Because you can ask your boss, okay, sir, before presenting, sir, see, actually I have no idea about this tier 1, tier 2, and tier 3. So at the time of presentation, he can at least tell you. Okay, and that's why I make a notes this way. Consider it as nominal because we are not clear. Okay, so you can ask your boss, sir, I'm not sure tier 1, tier 2, tier 3, this what is the order of the, it has some numeric weightage or not. If he says there is a numeric weightage, then ask him, sir, which should be more numeric weightage. If he says tier 1, then tier 1 should be given more numeric weightage, and accordingly tier 2 and tier 3. But if we don't know, of course, what is a better way? Consider it as a nominal. That is a better one. Or if you are getting a low accuracy, then you can try once again. Train your machine learning model once again. Instead of using it a nominal variable, treat it as an ordinal variable and try. Check, is the performance, there is improvement in the performance. If then use the ordinal only, right? That is important. Okay. Now let me move ahead. Again, this is what you see in supermarket type 1, type 2, type 1, grocery store. Can you make it out of this? Means it's a nominal or ordinal? Of course, it doesn't seem to me ordinal for now. See, let me check here. df super, what is the name of the column? Outlet type. Outlet type. Okay, dot unique. supermarket type 1, supermarket type 2, grocery store, supermarket type 3. From this, certainly you cannot comment. It type 1 may be, for example, having only furniture. Type 2 may be having only daily consumables. Grocery store, of course, is mentioning grocery store. Supermarket type 3 may be some electronic store. So you can't comment. It's okay. So of course, what you will consider it? Everyone? What you will consider nominal or ordinal?
Nominal.
Nominal, right?
Nominal.
Yes, it's a nominal, right? So we came across, okay, which column should be nominal, which column should be ordinal. Now come here. Every column has been gone through only except first column. Let's go through this first column, item identifier. Okay, is it unique? If it is unique for every row, of course you will drop it. But let's check. Is there indicating some information? So let me come here and check df item identifier. Okay, doc value underscore counts. Okay. So from this, let me, instead of that, it is not giving me proper information. Of course, it is not unique. From there, can you check everyone? It is not unique for sure because it is repeating 10 times. See, this is repeating 10 times. So it is not unique. So further information can be achieved by this. Let me use unique. Okay. So we have FD, we have DRC, we have FDN, NC, something available. Okay. And actually, I've gone through this data set. So understand what it means. FD means food product. Okay. DR means dairy product. Okay. And NC means non-consumable product. I repeat once again, FD means the starting two letters, whatever you are seeing, FD. Here, FD means food. Okay. Your DR means what? Dairy. Okay. And your NC means the thing which you can't consume. It's not eatable, non-consumable, something like this. Clear, everyone? So three things are there. Food, three products are there. FD indicating, DR indicating, FD indicating. Let's come there and verify from the results. Okay, from here. Example, let me come here. Instead of only 5 rows, let me see, suppose 10 rows. We'll get some idea. Come on. Numlog 10. Okay. Let's verify. Okay. So it's a dairy product. Item type is what? Dairy. Okay, fine. Sorry, I mentioned wrong. If you see here, FD means dairy. Okay, DR means drink. Okay, DR means drink. That's important to see. Yes, I was doing the mistake. It was DR means not dairy. DR means drinkable item. Drink. Okay, now let me move ahead. Okay, so your see dairy is your eatable product. Soft drink is drink. Again, meat is food eatable. Fruits and vegetable again see FD eatable. Household. Can you see everyone? Please see what is mentioned. Household. Household is what? Non-consumable. Can you see everyone? Please see. That is important to see. Baking goods, food. Again, snacks good, food. Snack goods, food. Frozen foods, food. Frozen foods, again food. Let me increase furthermore. So you'll get more idea. Suppose let me make it 30. Okay, we'll get some idea further. Okay, move ahead, move ahead. Come on. See, health and hygiene. What is that? Observe, please, everyone. What is this? NC, non-consumable, right? Hard drinks, DR, dairy, FD. Okay, again household. Can you see? NC, baking goods, FD, frozen foods, FD, household, again NC, right? So we are coming across everywhere three terms are mentioned, either FD or NC or DR. And what are the meaning of the same? Meaning is FD for food, DR means drink, and NC for non-consumable. So let's see, can we extract some insight from the same? Okay, so what is the information? Mainly these three things are required: FD, DR, and NC. So from this particular column that is visible to you, you have to extract this information because this may help us out. Starting two letters. It's eatable means food product, or it's a drink, or it's a non-consumable. According to it will help us in the sales. So from this particular column, you have to fetch starting two characters. This will help us out. Okay, so how can we fetch? Come here. Starting two characters are needed, everyone. Very simple. Starting two characters. So how can we fetch? Any idea? Come on, everyone. At least try. Maximum it will be wrong, no problem. How can we fetch? What is the column name? Item identifier, right? How many characters you want to fetch from the beginning? 2, right? FD, DR, drink. So let me copy this and let's experiment. Okay. I'm mentioning identifier. Okay. From this particular column, I want to fetch starting 2 characters like this, and this. So what I'm going to mention here again, apply. What? Why I want to apply? On every item of this, I want to apply a function. And that function should fetch what? It from every item of this particular column, it should fetch starting 2 characters. And what is the data type of the same object? Object is what? String. Suppose I mention here Python. Tell me everyone, this is the way to remember whatever you have studied, everything is going to come into the picture. S is equal to Python. If I say,
I
please
see.
give me, if you give me starting 2 letters, how will you give? Only starting 2 letters I want.
S and in bracket 0
0
colon
colon 2,
2.
right? This will give me. Okay. So we have to apply some function which can fetch just 2 characters. Okay, we have to apply a function. Same purpose was the apply now. Whatever function you want, if you want to apply any function, okay, on every element of the column that is available to you, you can use apply method. In apply method, you can mention what? This function which can extract starting 2 characters. So what function? Either we can create a new function and mention that function name. Instead of that, what I can do, I can use my lambda function. I will say that lambda. Okay, on the argument, only one argument is needed, that is x. Is individual value of a particular column, right? Colon. Then what I want to extract from this x? 0 colon 2. That's it, nothing else. Okay, so it will take every rows. This means it will go to this particular column, take every rows item, whatever is the item. For example, item is what? FDA 115. So FDA 115 will become what? X. Right? From that X, what do you want to fetch? You want to fetch starting 2 characters. So what it will fetch? Only FD. Clear everyone? Please tell me. Right? When it
Yes,
will go
sir.
to the next row, the X will become DRC 101. So DRC 101 will become X. Starting 2 characters. Take the starting 2 characters only. So what will become? DR. Right? So let me execute this. Done. And now let me check. DF item identifier. Okay. Let me just check dot value or dot unique. Let me pass unique. That is fine. We'll check it. Can you check? Only 3 values we are having: food, DR, and NC. Tell me everyone. Fine.
Yes, sir.
Any doubt anyone is having? Please, it's important. That's what I'm saying. Please.
Fine, sir.
Okay. It's awesome. It should be clear what is happening here. Okay. Now let me check my column complete data frame once again. df.head. Okay. So in item identifier column, we have the thing that we wanted. Awesome. Right? Food and something, it may help us out. Now this is fine. Now this is clear to us. We have done already cleaning of the same column. Okay. And here also visibility is fine, item type is fine, item MRP is fine, item outlet identifier is fine, establishment year is fine, outlet size is fine. Now everything is crystal clear to us. Okay. The only column that we will use for what? For particularly ordinal coding, that will be your outlet size, because it's clearly mentioning medium, high, and small outlet size. Other than that, whatever text columns are there, those are we are considering as your nominal variable. Okay. So how can we deal with such scenario? Simple. 2 methods are there for dealing with the ordinal data. We will go with the assigning the weightage according to their weightage, and similarly more numeric weightage will be assigned, higher numeric weightage to the thing which is higher in the hierarchy, or smaller weightage to the one which is having smaller in the hierarchy. And for nominal data, we will be doing one hot encoding. I think it should be okay for now. If it is fine, I can move ahead, everyone.
Yes, sir.
Okay, awesome. Now let me move ahead and do something further. What we have to do? Let's come here. Okay, so I'm going to come here. First of all, let me pick, remember that is the better way. Always pick first of all that column which you want to do the ordinal coding. Okay, that is your item outlet size. So let me pick it up. df outlet size. Okay, and we have actually checked also what are the distinct values it is having. Outlet size, where it is. And let me type again. If we are not getting it, let me type again. Dot unique. Okay, fine. Medium, high, and small. Actually, that will be needed. That's what I'm doing that. Now do the encoding. So how will we do the encoding? Remember, which will be highest in hierarchy, everyone? Medium, high, or small? Which will be higher in hierarchy? Means medium or high or small?
High.
High,
High
right?
will be high.
So more numeric weightage will be given to high. Okay, and which will be given the smallest weightage, that will be given to the small. Okay, so we'll mention again equals to same column name. Now we want to apply in that same way that we applied earlier, exactly same way. I'll mention here dot map, the way we mentioned earlier, right? Map. What? A dictionary here. And in dictionary, mention whatever you want. Okay. Wherever there is small, SMALL, just ensure that spelling is correct. Otherwise, if you missed, trust me, everything will be wrong. Okay. Small. Whenever it is small, I want to give it a numeric weightage of 1, like this. As simple as that. Okay. Wherever this is medium, okay, I want to give it a numeric weightage of 2. Means wherever small will be there, it will be replaced by 1. Wherever medium will be there, that will be replaced by 2. Because machine learning model, remember, only understand numbers. So you have to replace everything by the number. So first text column, which is an ordinal column, okay, we are replacing small by 1, medium by 2. And again, what is last? High. We'll replace it by 3, like this. Okay, please check everyone and let me execute this. Done. And let me check again. df outlet size dot unique. Can you check everyone? Please see properly. So everything in your outlet size has been replaced by the text. Now no longer it is showing medium, 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 high, right? Now let me check our data frame. df dot head. See what it is. Where is outlet size? Can you see everyone? It has changed to number that we want. Clear? Please tell me.
Yes, sir.
Okay. Now further, the remaining text column, this text column, this text column, this text column, this text column, even this text column and this text column will be done in one line, no problem, because these are what? Remember, these all are your nominal data. So nominal data can be treated in one line, no problem. But I will mention very, very simple. You have a direct method available for the same. What is the method name? pd dot get underscore dummies. Okay, within that you can pass directly your data frame. Okay, so what it will do, it will pick your data frame, and within that data frame, whatever numeric columns are there, for those all the numeric columns, it will create the dummy variables. You don't have to worry at all. In one line it will do. That's why I said, okay, it will treat every column, whatever text column are remaining right now, whatever text column you will pass, sorry, whatever df you will pass. So if there are 15 text column, it will treat all the 15 column text columns to be what? Remember, nominal data. So it will do one hot encoding for the same. So if you want somehow ordinal coding, means coding as per the ordinal data, so do that first. Because what will happen if you directly pass your df here, it will treat every column or every text column to be what? Nominal data, and do one hot encoding. Okay, that's why intentionally I did this first. Okay, otherwise if I would have directly passed this data frame to my pd.getDummies, even this would have been considered like nominal data. Okay, that's why I said that first of all deal with the ordinal data, do the proper encoding, now use your text data. That's what we have to do. Okay, and assign whatever it will return to the df, like this. Okay, and there is one more parameter people use that's very good actually. What is that? Drop underscore first is equal to true. Why is the purpose of the same? Let me tell you one thing. Let me open a notepad. Why we use it? Suppose we have a gender column. okay, in which we have column known as male, we have female, okay, again we have a male, again we have a male, again we have a female, okay, again we have a transgender, okay, suppose trans I mentioned, then we have again a female, okay, and then again we have a male example, okay. So what, how the one hot encoding works, okay, it will see how many distinct values are there in this particular column, how many distinct values are there, male, female, and trans. It will create 3 new columns, right? Let me drag it upside. Come on. Yeah, it will create 3 new columns, male, female, and trans. And how do you mention? It will come to the first row, okay? What is the mention in the among these 3? What is mentioned here? Male. So it will be marked as 1. Female will be marked as 0. Trans will be marked as 0. Come to the next row. Okay. What is available here? Female. So in male, 0. Female, because female is present, so 1. Trans, 0. In male, again next row is male. So again in male, what we will get? 1. Female, 0. Again trans, 0. Okay. Same thing here in the next row because male is there. Okay. And female is there, then the same result. Okay. But what in case of trans? Remember, when trans is there, in male we will put 0. In female we will put 0, but in trans we will put 1 because it is there. And again female, same, 0, 1, 0. Okay. And again in the last male. So in male, 1, this 0, and this 0. Okay. So normally it creates 3 columns. So if I don't specify this argument, drop first is equal to 0. Okay. So what will happen? For every column, suppose in this column, remember in item identifier, we had 3 values, FD, DR, and NC. So how many new column it will create for you? Everyone, how many new columns it will create for you? I just told you how many unique values are there in this particular column. 3, FD, DR, and NC. So how many new columns you will get for this particular column?
Just
3. 3 columns, right? So for every, it will create every column, it will create that many number of columns, that many distinct values are there. Okay. But if you mention drop first is equal to true, it will create drop 1 column like this. Male will not be there. Remove this. No longer required like this. If I mention drop first is equal to true. And still it will communicate the same information. How? See. Okay. It understood that I am dropping 1 column. Okay. So it come here. Come to the first row. In first row, what is there? Male. Female is 0, trans is 0. Means, of course, it is neither male nor transgender. That means it belongs to a third category. So automatically you understand it belongs to the third category. What is that category? Males. Right? No need to bother because automatically same information is communicated. When it is female, then of course female, no problem. When again it is a male, see what it is here. Neither she is female nor transgender. Then means both conditions are not satisfied. Neither female nor trans. That means something different. What is something different? Male. So even if we drop first column or 1 column, still same information is achievable. Okay. That's why it's recommended to mention what? Drop first is equal to draw. Clear everyone? Please tell me.
clear, sir.
Okay. That should be okay. So let me now execute. And now let me check df dot head. Now everywhere you will get only and only numeric columns. See? First item weight, which was a continuous numeric. Visibility fine. Item MRP fine. Establishment year is fine. Outlet size is fine. Outlet sales is now see. Now here comes the things. Can you see? A column corresponding to FD, a column corresponding to NC, but there is no column corresponding to DR. Can you observe everyone? 3 columns were there. 3 distinct values were there. FD, NC, and DR. Food, drink, and non-consumable. But what it is considered only 2, food and NC. Can you see? Please observe, right? The drink is not there, right? So accordingly, see, everything is numeric right now. Everything is numeric. Yeah, please tell me. Now nothing is numeric. Now your model is ready for machine learning. No problem. Right? So once it is done, what's your next duty? Once it actually somebody's background voice is coming. Okay, now come here. Okay. Once your everything is numeric, now no problem. Now separate your input variables and the output variable. What is your output variable? Your output variable is the output that you want to predict. What is the output? Item outlet sales. So let me separate them. Okay. So I mention here what, see, my output variable, that is my y, is equal to, from df, I want to pick only and only what? Item outlet sales. That is the only thing that I need, nothing else. This is my output variable. Okay. So I'm separating what we are doing, separating input and output variables. Okay. So y, this is my y, and what is my x? Other than this, everything is my, other than this column, other than this particular column, everything is my input. So I'll mention x is equal to df. Everything I want from the df except, so which I don't want, item outlet sales. So I'll say drop from df what? This particular column. What is the column name? Item outlet sales. Same column, this column. Means drop, except this column means drop from the x, this particular column. Okay. So if you'll drop this particular column, but I want to drop a column, okay, not row. So I'll mention here what? Understand? Axis is equal to 1. Then only I will be able to drop the column. If I mention x is equal to 0, it will say, okay, this particular thing is not found. Let me show you that. Suppose I came here and mention here, I don't mention x is equal to 1. Okay, let me execute this. See what I'm getting. It will show not found in the axis. Can you see? Because by default, it searches where? In the row only. So in a row index here, nowhere your item output sales is mentioned. Okay, so you want to search here. That's why you have to mention axis is equal to 1. Okay, that's why I mentioned here. So I mentioned df dot drop. So everything means drop from the df what? This particular item. Okay. After that, whatever is remaining, that is your x. Okay, but this is not happening in place. So after even dropping, your df will be the original df, the way it is. That's why from the complete df, I am fetching my output column. Whatever is my output column. So you will mention df dot drop, your output column, drop from the df, your output column. Okay. And after dropping, whatever is remaining, that is your x. Okay. And from the complete df, just fetch one particular column known as item outlet sales. So let me execute this. That has been done. And now let me check x dot head. In this, you will get entire df, but you will not have item outlet sales. See, earlier it was there. If I show here, item outlet sales. Okay. But come here, check. We don't have an item outlet sales here. Okay, rest all the columns are there. 5 rows, 37 columns. Okay, and if you see here in your df, 5 rows and 38 columns. Now what is that? 5 rows and 37 column, because one column has been dropped. That's what is your axis. Okay, and what is your y? You can check y dot head. This is your item outlet sales. Okay, so what you will do after ensuring that you don't have any missing values, all your text columns are converted into the numeric column as per the requirement. You will separate your input and output. And how do we separate? Same process, nothing special. df dot drop, just mention your output column name, x is equal to 1, and y is equal to df, in square bracket, your item output sales. So your x and y is separate. Now it's come further. Now what is the task? This is your data, entire data which is given to you. Now you will divide your data into two parts further, training data and the testing data. Okay, now you will divide your data into two parts. So now actual machine learning will start coming into the picture. Okay, for the same purpose, actually, you have to import some libraries. What is the library this time? Import scikit-learn. So you mention sklearn. This library is scikit-learn, basically for the machine learning only, right? Done. From this library, I will import something else. What? From sklearn. Dot model selection. Okay, I want to import a library known as train test split. Basically, it's a method. Okay, train test split. Done. Okay, so what it will do, whatever data set is given to you, okay, whatever data set, in data set, how many rows are there? 8,523 rows, if I'm correct. Where is that? Where is that? Where is that? Come on, come on, come on. Here is that. Okay, this is entire data set, 8,523 rows. Okay, so we don't use entire data for the training purpose. We use normally, what is the rule? 75 to 80% of the data we keep for the training, and rest 15 to 20 to 25% data we keep for the testing. So we will divide our data into two parts. How? Let me show you that. Suppose notepad is there. Okay, so we have some data available. Okay, suppose row 1, okay, row 2, something, row 1, row 2, row 3, row 4, row 5, something like this mentioned, right? Row again, suppose row again 8,000, something like this. So what we will do, we will divide our data into two parts. What are the two parts? One is your training data set, we will call it. Okay, we'll divide the training set, and second one will be test set. Okay, how many data is there total? In total, suppose we have 8,523 rows. So out of these 8,523 rows, 75 to 80% of these, okay, 75 to 80% of these, how we will pick? Randomly, not in sequence, row 1, row 2, row 3. 75 to 80% of the rows we will keep in where? In training set. Okay, for training of machine learning model, from which your machine learning model will run, and 25 to 20 to 25% data will keep for testing purpose. Okay, 25 to 20 to 25% will keep for testing purpose. For the same purpose, we have to import a library known as train test split. So we'll import train test split from where? sklearn.model selection. What it will do, it will pick randomly what will be 75% approximately of the 8,523. I think around 6,000. Let us say that 6,000. So 6,000 random rows will be picked from 8,000 rows. Okay, 8,000 random rows will be picked, and that will become a part of training set, and remaining will become a part of test set. So my machine learning model will be trained on training set. Rest of the data will be kept here. Suppose I decided I will keep 80% for the training. This is my rule, and I will keep 20% for the testing. Okay, so let me come here and let me open a calculator. Okay, suppose I said 8523 multiplied by 0.8. Sorry, I wrong type. 8523 multiplied by 0.8, right? So 6,818 rows. Okay, so 6,818 rows will be kept in the training set. But how these rows will be picked? Randomly, remember, randomly, not in sequence. Okay, and remaining rows, what is that? 8,523 minus 6,818. 1,705 rows will be kept for testing purpose. My machine learning model will be trained on these rows. Okay, so how will we divide them? We will divide them by a function known as train test split. Okay, the train test split, we were using by train test split. Okay, so train test split is going to help us out, and it will divide our data into train and test, but it will give me 4 arguments. Let me show you that. Is it clear, everyone, so far? How will we deal with our data? Whatever our data is, it will be divided into how many parts? 2 parts. One will be training, one will be testing. What is the normal rule? 75 to 80% for the training, 20 to 25% on the testing. And machine learning will be trained on which data? Remember, always training data.
Training data.
Okay, always your machine learning trained model will be trained on training data. Clear so far, everyone? And how will we pick the 80% data? Randomly. Okay, so how will we do that? See, I just imported a library, I guess, here. Train test split. So I'll mention here what. See, that is very important, right? So actually, I will mention here train test split. Okay, this is my. I mention here what. You have to supply X. X means your input variables. We have supplied this. Now. This is that's why we separated. That's why we separated our input and output. This is our X. That is input variable. Pass your input variable. What is the name? X. Okay, name anything you can give. It's your choice. Okay. Now your output. What is output variable? Y. This is what we. That's why we initially separated before this step. X should be separate. Y should be separate. That's why you pass input and output. Now you will specify what your test size. Okay. What is your test size? Test size. I mentioned 0.2. That means 20% of the data you have to keep for testing purpose. Okay. And 80% for training purpose. And one more argument known as random state. Okay, any random state you can go. As I told you, it will pick the data randomly. If I don't specify this, see, suppose if I don't specify this anything, then every time you will execute your machine learning, then every time 80% of the training data will be picked randomly. Every time you will get a different result. Okay, but if you want every time randomly it is picking, but randomly that too should pick in a particular order, whatever is specified. Every time you should get the correct result. Means in training set always you should have the same data which is available. So I am testing today, tomorrow, or day after tomorrow. So if I don't specify random state here, right, then I will check the result. Today result will be different, tomorrow result will be different, other day result will be different. If I want one result to be at the same time, I have to specify random state. Okay, suppose I mention 42. Any number you can give. Okay, normally 40, between 40 to 50 we specify, but you can specify anything. Okay, that's the issue. And it returns you four things. Remember, you will pass X and Y. It will give you four things. What? It will give you X part of the training data, X train. Okay, it will give you X part, means input part of the test data. Fourth thing it will give you. Okay, it will give you Y part of the training data, means output part of the training data. And it will give you Y part or the output part of the test data. So four things it will return to you. Okay, it will return four things to you. I pass my input variable, I pass my output variable, I specify test size, I specify random state. And what it will give me? It will give me four things. Okay, input part of the training data and the corresponding output part. Input part and the corresponding output part. Okay, input part of the test data and the corresponding test data. Okay, so four things it is going to return me. Let me execute. Done. It has been done. So I have four things available: X train, X test, Y train, Y test. That's done. But now what is required? See, our KNN algorithm is it's taking too time, but actually it's important to understand. That's why I'm taking time to explain. Everything is very important. If you miss one thing, trust me, your life will become hell if you don't understand properly, think properly. That's why I'm taking time. Okay. In one algorithm, it will take time. Next, we will do that. Every step is same. Okay. So if you understand one model very well, the rest of the thing you can do in 15 minutes, not a problem. And any other machine learning model, because just understand the process. Okay. In every machine learning model, the step will be followed, that whatever we are doing right now. Okay. Now what happens? Understand. We saw here, okay, we have a numeric data. Okay. But if you see the numeric data, somewhere the number is 19999. Okay. 2009. And somewhere it is 2, 2, 2, 3. See the scale. Okay. See the scale. The scale is within one digit, right? Here the scale is in
कूलर
thousands.
चला दो बापू जी
Okay. Similarly, see here it is in 100. Here it is even very, very
100
small.
मैं चला दूँ
Okay. Here it is even very, very small. Even less than that. Here it is even different. So what we want to do? We want to bring them in the same scale. So whenever your algorithm is some distance based, in KNN is of course a distance based algorithm in which we use Minkowski distance, right? Or Manhattan distance, or your Euclidean distance, or your Hamming distance. So it's a distance based algorithm. So whenever distance based algorithm is there, you should ensure that all the columns are in the same numeric scale. Okay. So for that purpose, what we can use, we have two methods there, everyone. Remember, we have two methods for the same. Let me show you what are those methods quickly. Okay. Implementation is code I will write, it will take barely 5 minutes. Don't worry. Okay. Theory is main important. Coding is very, very easy. What is that? Two methods are there. Min max scaling. And second one is standard scaling. Okay. Min max scaling, some people call it as normalization. Okay. And standard scaling, some people call it as standardization. So any one of these you can use. Normalization or standardization. 10 minutes more I will take, everyone. Okay. Is it fine if I take 10 more minutes? Is it okay, everyone?
Yes,
If I
sir.
take,
Yes,
okay.
sir. No issue.
Okay. Okay. See, normalization. What we do? Suppose I have a column X. Okay. In this X, we have a value, suppose 10, 20, 25, 30, and suppose again 5, and again suppose 50. Okay. So in min-max scaling, you will find out two parameters. What will be that? What is the minimum value available inside particular column? So two values you will find. One minimum. So what will be the minimum value in this particular column, everyone? Can you observe? What is that? 5. Okay. Second parameter you will find is the maximum value. So what is the maximum value in this particular column? 50.
50.
Okay. So this thing. Now what you will do? How will you scale this? You will scale it this way. 10. This value will become what? Understand, 10 minus minimum value. 10, what is the formula? Let me write here. That will be easier. Okay. That will be nothing but xi minus x min. Okay. Means the current value of x minus whatever is the minimum value available in this particular column. Let me mention that only min. Xi minus min, this one, divided by max minus min. Right? So what you will do, this is known as min max scaling. Understand? You will take an individual value of a column. From that, you will subtract what is the minimum value and divide it by whatever is the difference between max and min. Okay. For example, so what is the individual value here? 10. What is the minimum value, everyone? 5. So 5 divided by what is the difference between max and min? So what is max? 50. What is the min? 5. Okay. So what value actually we will get? We will get value equals to what numerator will give us? 5. What denominator will give us? 45. Clear, everyone? This line is clear? What I've done? Please tell me.
Yes, sir.
Okay. This thing should be clear. Now, similarly for the next row, come here. You know, tell me what will be the value? Same process. Tell me. 20. What is the minimum value? 5.
5,
Divided by what is the maximum value? 50.
50,
What is the minimum value? 5. Okay.
5.
So if effectively what we will get? We will get 15 divided
15
by
by 40.
40. Similarly, come to this row. What is that? 25 minus 5 divided by again 50 minus 5. I think should be clear, everyone, how I am calculating.
Yes, sir.
Right? So what we will get this time? 20 divided by 45. Okay. So if you see properly, can you tell me what can be minimum value in this particular column? Means after scaling. After scaling, what can be the minimum value and what can be the maximum value?
Zero and one.
Yes, very good. Minimum will be 0 and maximum will be 1. When will we get? Let me accuse it. Let's see. Let me calculate this one as well. 30 minus 5 divided by 50 minus 5, like this. So what we will get? 25 divided by
25 by divided by 40.
now come here, right? Tell me this one, everyone. 5 minus 5, right? 5 minus 5 divided by 50 minus 5.
50 minus
So what it will be? It will be nothing but 0, right? Come here. What it will be? 50 minus 5 divided by, again at the bottom, 50 minus 5. What will be the 45 divided by 45 will be what? 1. Right? So every value, doesn't matter what value we are having here. Okay, it doesn't matter what value we are having in a particular column. The minimum value will be 0 and maximum value will be 1. So the value of the columns will be in between 0 and 1 all the time. Clear, everyone? Doesn't matter. I put it thousands here or I put tens here, I put hundreds here. Always the value will lie here between only 0 and 1. Clear? Please tell me.
Clear, sir.
Clear, everyone? So now let me use it. See how well we do it. I'll tell you the standardization later on, but understand basic purpose so that we can solve the problem. Okay. So let me use first of all this one. Come here. For the same purpose, we'll import a library. How will you import a library? I will say again. From sklearn dot pre-processing import what we want to import min max scaler. Just execute this min max scaler. Okay. Just a second. Min max. They have changed something. Let me again do scaler dot pre-processing import. Yeah, standard not standard scalar. We went min max scalar min. Yeah, min max scalar. Right. This is the scalar that we want. Okay. Let me execute this. Okay. And min max scalar is a class. Okay. So we have to create an object of the same. So how will we create an object? So suppose I mention here a scalar equals to min max scalar. Okay. So I create an object of the same class. Done. Now this object has two methods. One is fit and one is transform. Okay, it has two methods. Remember, fit and transform. In the fit, what we'll do, we try to find out whenever fit is there, we'll find out these parameters. What? Min value and max value. Okay, in the fit method, so we find out min value and the max value, right? And always remember, whenever you are doing the fitting means you're learning something. So learning always has to be done on the training data. Remember that in mind. Learning always has to be done on training data. So you will find out these parameters min and max from the training data. So what I'm going to mention here, see, okay, I just did that. Let me execute execution has been done. I will mention here what the name I've given is scalar. Okay, dot fit. And at the same time, I'm using one more method. You can use twice, two steps you can do. One, you can do fit, then you can do transform method. Two methods are there, fit and transform. In fit method, we learn min and max value. In the transform method, we transform the value of the columns. Okay, but you can do in one line. What? Fit underscore transform. So two steps can be done at the same time. Transform. Fit underscore transform. Okay, and from which data we want to do that? From the X training data only. Okay, and this will become my scaled training data. So I can mention X underscore train. Suppose I mention to differentiate scaled equals to this. So what it will do, we have created an object of the same. This object has a two methods available. If in fact fit method and the transform method, we are using one at the same row. In fit underscore transform method, first of all, fit will happen. In the fit will happen, we will run from the X train for every corresponding column min and max value. And according to the min and max value, these column value transformed like this. These values will be transformed like this between 0 and 1. Okay. Similarly, same way we have to transform our data for the text data, but only transform, not test. Remember, for test data, you will do only transformations. You will again mention here X, come here, X underscore test underscore scaled is equal to scalar. Okay. Dot transform, only transform. Remember, fitting will always have only on the training data. Okay, never on the test data. Okay, so from the same parameters, min and max values, you will transform our X test data. So transform what? Our X test. So test data always transform will happen, and on the training data, fitting and transform both will happen. Remember that thing. Okay, so I repeat once again, we want to do the scaling, and which kind of scaling we want? We want min max scaling, so that every column of the data set, whatever your data set is, comes in the same scale between 0 and 1. So we choosing the method to be min max scaling. Okay, so how we will use the min max scaling? You mentioned from sklearn.preprocessing import min max scaler. That has been done, and we get an object of the same. This object has two methods, fit and transform. With the help of fit method, it learns the parameters. So what are the parameters in this case? Min and max value. So it will learn the min and max value, and after learning the min and max value, I use one more method in the continuation known as transform method. So after learning, it will transform corresponding training data. Okay, so that done, and after that you will get transform your extreme data. But remember, in on test data, we will do only transform, not fitting. Not fitting. We will use the same parameters X, which has been learned by this method. Same method we will use, only we will transform across this. Means even X test data is given to you, but for transforming your X test data, same min and max value, which has been computed by your this method will be used. Okay, so let me execute this, and you can check now what happened. Oh, I executed this scalar spelling mistake. Okay, the scalar, this one, scalar. Yeah, now done. Now check everyone. X underscore train underscore S. If you check dot head, I think it's a numpy array. No issue. Dot values. Let me show you. Okay, let me just directly show you. No problem. Can you see everyone? Every value here is between 0 and 1 only. Okay. Same way you can check your X test if you want. X underscore test underscore S. See, every value is between 0 and 1, 0 and 1. And you want to compare with your original X test, just check X underscore test. See the values. How are this? 14, 15, somewhere 179, somewhere 987. Here, all the values are between what? 0 and 1 only. This is what we want. And your most of the work is now only machine learning model is required. Your training data is ready. Your testing data is ready. First of all, see everyone, and this any doubt, please ask me right now. I'm not in hurry. Please see it. That is important actually. If you learn this very well, trust me, rest of the algorithms are very easy for implementation, because in every algorithm, whatever steps we are doing, we'll follow the same steps. Same steps you are going to follow in every algorithm that we are going to study. Please see properly and tell me.
Sir, can you scroll up a little?
Sure, sure. Here.
Sir, in this line 96,
Mm-hmm.
when we split up our training and testing data, so
Mm-hmm.
is it mandatory to write in this particular order, that first X train, then X,
Yes, yes,
X test?
exactly. Yes,
Because
same order. Yes, same order, same order. Exactly same order. It's
okay, okay,
mandatory to mention in the same order, the way we are mentioned.
okay, that was the only doubt, sir.
That is in the, yes. Other everyone clear? What is the purpose of the scaling? Is it clear? Why we did the scaling? Right?
Yes, sir, that is clear.
Okay. And why we are doing? Remember, only training data. What we will do? Fit and transform. But on the test data, what we will do? Only transform. Remember that. Only anything fit is there. Remember, only that will be done on the training data, never on the test data. Fitting will always be done. Fitting is learning. Learning will be only done on the training data. Now let's build our model. Now damn easy. Where did we define that? This is where we mention here. See, this is the way we mention a test size. See, test size is 0.2. That means obviously understood training data is what? 80%. Clear, Varun? We have specified my test size is 20%. That means my training test size will be what? Automatically 80%. Clear, Varun? Tell me. Yeah, this is what the thing. So you mentioned just one thing, it will be done. Now see, only one line, only 1-2 lines are remaining now for building machine learning model. So now we need machine learning model. Which machine learning model we need? We need KNN, right? So I'm going to mention from sklearn. Okay, dot neighbors, NEI, just press, automatically it will take. And this is a regression problem. So I will mention import K neighbor. See, two options you will see. Classifier and regressor. Can you see everyone? This is the one two needed. Classifier and regressor. We need regressor. Just click on the regressor, because our requirement is a regression problem. If it has been classification problem, I will mention classifier. That's it. Only difference. Done. Okay. And it's also in class. So let me create an object of the same again. Okay. So I mention here K neighbors regressor. An object name I'm giving a model. Okay, and it's one argument. If you don't specify, although it doesn't matter, one mandatory argument it needs it. Not mandatory, it automatically takes. Remember, one argument is important. That's what I should say. There is one important argument. Other you can use for the what should I say? Parameter tuning. Other parameters you can use for the parameter tuning, but one is very, very important. This is also used for the parameter tuning. You see, several parameters are there. Can you see one thing, everyone here, please? What is mentioned here?
Minkowski. That means we have to enter either we want to use Euclidean or
No, don't worry, don't worry. For the same purpose, P is also given. See,
okay,
automatically
right.
P is what? 2, right? P is 2 means what? It's equality and distance, right or wrong? P is equal to 2 is
Yeah,
what? Remember we discussed. So automatically it is doing what? In equality and distance for you. It is calculating equality and distance for you, because P is equal to 2 here. So under root of x2 square minus x1 square plus y2 square minus y1 square. So automatically it is going to do P is equal to 2, right? And very, very simple, very important thing. This is the very important thing. Then neighbors. How many neighbors you want to pick? Remember, one argument was very important. How K nearest neighbor? So how many neighbors you want to pick? Okay. So if you don't specify, by default, what it will take? 5. Right? If you don't specify, by default, it is going to take 5 only. Okay. That's what I say. It's not mandatory, means nothing is needed. Means if I don't specify anything, it will work. No problem. Even it will work. Okay. Suppose I come here and mention n underscore neighbors. This is how we specify. Suppose I mention 5. So 5 is already there, but how will we specify 5, L7, 11, 13, 15, whatever you specify there. Just execute this. Example done. Now what you have to do? You have to train my model. So how do we train the model? Model dot fit method again. And how do we fit? Remember, always on the training data. Okay. So here we will mention, please learn. How will we learn? We learn from the X train underscore S scale data. Okay. And Y train. So scaling has been done only on X data, right? Only X data we trained, scaled. See, only X data we scaled, okay, not Y data. Okay, so you mention your X scaled, this one, and your Y train, corresponding Y train means this is the input and this is the corresponding output. This is what you are telling. This is the input, this is the corresponding output. Now try to learn, just execute this. Okay, so your model has been trained. Done. Now you can predict. See, so again, there is a method. This is a method for training. This is no model is getting trained. Now you will say model dot predict. Okay, and from which we want to predict, we want to test our model, how my model is getting performed, how it is performing well, right? For the same purpose, normally you want to check, okay, how my model is performing on the training data, then you can pass your X train here. But better is what I'm passing here, my X test underscore S scaled test. Okay, and from this it will predict my Y value. It means output value. So that will save in the Y. Suppose I'm saying Y prep. Okay, so it will predict the value of output variable from my test variable according to the learned by whatever has been learned here. Okay, this model has been learned from that learned model. I pass my X test, and remember, X test we never pass to the model. Never pass. What we pass to the model? We pass to the model only training data, not testing data. This is unseen data. So I'm checking. Please test how my model is performing on the unseen data. Let me execute this. So it will give me corresponding Y value. Execute. It has been done. But let me check Y pred. What is the Y pred? Value is getting some continuous numeric output. Fine, no problem. I'm getting that. And what is my actual output? If you come here, what is Y test? Okay, there is, I think, different name we have given, Y underscore test, if I'm correct. Yeah, this is the one. Okay, it is giving me some outputs. But let me check how much error we are getting, how much model my correct is. For that purpose, actually, we need some matrices. Okay, what are the different matrices? Mean absolute error, mean square error, root mean square error. How do we calculate them? See, very, very simple. Very simple. So, okay, suppose this is your predicted value. Okay, and your actual value is Y test. Actual value is Y test. So what is the mean absolute error? See, mean absolute error. How do we compute? Suppose for first data point, let me come here and it's better I take it this one. Okay, suppose my for first data point, my predicted value is Y pred I. Right, and actual value is Y test I. So in what we do, we compute the difference of this and take the mod of these like this. Plus, come to the second point. For the second point, for example, this. What is the corresponding test value? So Y test, suppose this is 1, this is 1, this is 2, Y test 2, minus Y pred 2. Okay, plus again Y test 3 minus Y pred 3. Means corresponding data point, what is the corresponding test, actual test value? Okay, what is the corresponding output for the test value, and what is the prediction? So we compute the difference between them. We want to find out the error, right? So what is the error? We take the mod of this corresponding Y3. Okay, similarly you will mention that. And if I summarize this, we can write this way. What is this? Mod of Y test I mentioned this time, okay, minus Y pred I, okay, summation I is equal to 1 to n. Suppose there are n points available, okay, and it is what? Mean absolute error, mean. So it will give you absolute error. You take, suppose you have n points, so compute n of these. So it will become your mean absolute error. Tell me everyone, is it fine? How I computed this? Please tell me. This is the predicted
Yes,
value by the model, and this is the actual value. So actual value minus predicted value for first point. Actual value minus predicted value for second point. Actual value minus predicted value for third point, and so on. Continue. Okay. So same expression we can continue in what? Y test I minus Y predicted I is equal to 1 to n summation divided by 1 by n. This is what? Your mean absolute error. Okay. Similarly, you have mean squared error. Okay. Remember, mean squared. Squared means same thing you will do this time. Instead of squared error, how will you compute the squared error? You will compute this way. Instead of mod, take the square of this. Instead of mod, take the square of this. Instead of square, make square of this. Like this. Compute the square, first of all, square error of everything. Okay. Compute the squared error of everything. Mean squared error, I'm talking. Mean Squared error. So first of all, compute a squared error, right? So squared error, how I can mention same way? Same way, I can mention here parentheses of square. Okay, same thing. Why first point minus second point square. Second point minus second means actual value minus predicted value square. Actual value minus predicted value square. Actual value minus predicted value square. Keep on. This is what sum of error. Sum of squared error. This is what sum of squared error. So same thing I can write by this, everyone. Y test I minus y predicted I whole square. Can I write this or not? For the end data points? Same formula.
Yes,
Can I
sir.
write? Okay. And when I said mean, so mean means divided by n. This becomes your mean square error, right? There is third more matrix, RMSE. That is root mean squared error. Root of mean squared error. In simple as that. Root of mean square error. Can you tell me how I can compute? Root of mean squared error. So this is what you are seeing right now. What is this? Mean square error.
Mean square error.
So how do we compute the root mean square error? Just take the under root of this. That's it. So under root of mean square error is nothing but what? Root mean square error. Tell me clear, everyone. That is important actually. Very, very simple formula. You don't have to mug up. I think very simple formula these are. Very, very simple formula. Tell me any doubt in this formulas, everyone.
No doubt, sir.
Okay, it's very simple. Now see how we will compute that. We don't have to manually calculate these. See, we have to just import them. So I'm going to say from sklearn dot matrix import. Suppose I import mean absolute error. Okay, comma mean square error. Mean squared error. This done. Now see, damn easy it is. Very, very damn easy. Calculate mean absolute error. Okay, it needs two arguments: true value and the predicted value. See, y true and y pred. Y true and y pred. What is the y true value? Y underscore test. That is the true value of your test data. Okay. Now predicted value. What is the predicted value of the corresponding x test data? Y pred. So y pred. It will give you the mean absolute error which is available right now. Similarly, mean square error. Mean squared error. Same two argument it needs. True value and the predicted value. See, true and predicted. What is true value? Which data we have used? X test data. So what is corresponding true value? Y test. And what is corresponding predicted value? Y pred. We get the corresponding values. This is how we compute. Tell me, everyone. This is the entire process that we do in the beginning. And you can do much better than this. Whatever we are getting, we can improve this. If we devote time 5 to 6 hours only in what? Understanding our data much better. What is the relationship? What is the correlationship between these columns? Identify. What is the relationship between your output column and that whatever visualization, remember we discussed everything means outlet sales. What is the impact of outlet step on the outlet? What is the what is the effect of outlet type on outer item outlet sales? Is there any impact or not impact? We can check quickly and we can come across what is the information available. Okay, for example, what I want. See, come here. If I execute this, actually we have changed that, but no problem. We can say import. I think we have imported C1 already. SNS dot bar plot. Okay. In X, what we want? In X, we want, what was the name? Outlet type. I gave you same task on the Saturday. Okay, please go through that. Outlet, come on, take it. Outlet underscore type. I think this is the name if I'm correct. Come on, come on, come on. Yeah, outlet and type. Where is that? Outlet type. In Y-axis, what you want? Your item outlet sales. Item sales. Mention here, yes. Okay. And your data is equal to DF. From this, you will get an idea what is the impact of this item outlet sales column sorry, impact of outlet type on the item outlet sales. Is there any impact or not? What is the problem? What is it saying? Cannot. Okay, I think I mistyped something. Let me just copy this. Okay, got it, got it. Actually, we have changed that, right? That's why the problem is. We have changed the column. Already we have done the everything. Let me do one thing. For the same step, let me show you here. Now, just a second. Come here, come here. Where is that? Where is that? Where is that? Yes, let me execute it once. Okay, and let me show you same thing here. Come on. Whatever is it, let me copy this. Where I was doing. Just ensure that your column names are correct. Only thing is that is required. Where it is gone. See, so certainly we have an impact. Can you observe, everyone? Which is the largest effect? Supermarket type 3. So you can get, yes, what is the impact? What is the major impact? So if you find everywhere, suppose something, you get this kind of graph. If you're getting this kind of graph everywhere, same there, here, 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 same size, suppose. Like this. Everywhere same size. So is it any point in taking this column? Tell me.
No,
Is it
sir. We would
right?
have dropped that column.
Yes, we would have dropped that column. Perfectly. Okay, that's why spend time on the data analysis. See, we have been doing the same problem for the 3 days, right or wrong? Same problem. And if I trust me, if somebody asks me make it better, I'll take at least 1 to 2 days completely. Spend 5 to 6 hours, 8 hours even on the data analysis only, analyzing every text, every fact. That's what I told you on the Saturday. Please go through this and try to do EDA. Try to experiment every column. What is the column? What this information is communicating? Okay. And whatever I have done, I'll advise you, please try to improve this. See what is important, what is not important. But every process you have understood, I think.
Yes, sir. But one small thing,
Mm-hmm.
sir. While doing this, sir, why did we skip the outliers part? We didn't
No,
dealt
no,
with
no, no,
outliers
that should be done.
in
That
this.
should be done. Actually, I did only the mandatory part. Of course. Yes, that's what I told you. We should have done that. I've just done the mandatory thing which was required. I've not done that. Absolutely right. That should be a part of the same. Absolutely part. Okay, that's what you should. Now you do one thing. Okay, whatever I have done, try to improve that model. That's what I was saying. Okay, try to improve that and remove the outliers. See the outliers. What are the outliers there? Of course, you should do that. I intentionally didn't that
Sir,
because yeah.
I would try to do that
Mm-hmm.
to remove the outliers using box plot only
Mm-hmm.
in this data only. And
Mm-hmm.
while doing so, I'm having I'm having a kind of a doubt. I'm having.
What? Tell me.
Uh, can we plot the? Can you please plot the bar plot of? Wait a minute. Let me tell you.
Mm-hmm.
Which column was that? Item visibility column.
Sure. Box plot, na?
Yeah, box plot. Sorry, not bar
Okay.
plot.
No issue. Uh, Item. Let me mention here. Df x is equal to df. Item visible. Come on. Remember, what is a better method of removing? The method is same follow. Just remember, I showed Q3 plus 1.5 times IQR. That is a better method of
Yes,
removing.
sir.
Follow that one. There's one more method. I'll tell you that. Don't worry. There is one more method by using Z score. We can do that. Yeah, this is the one.
Okay. So the max point in this one
Mm-hmm.
is apparently close to point 2, right?
Yes. Apparently, means point 2 is even above than that.
Above point 2, right? And
Mm-hmm.
after that, we are having our outliers, right?
Yeah. Yes.
So after doing that, when I check the same thing using describe method, that we write df dot describe and then uh, bracket, it is showing some different value.
Means what different value?
So uh, it was showing max value close to 0.32 something something.
Mm-hmm. No, no,
Can you please
that
just
is
write
different. That is different. Remember how this max value is computed. That is the max value in an entire column. What you are seeing now, this one. This suppose this is the same thing. Now, if I use this,
hmm,
this one, okay, item visible, I go put tools. It will show you the max value. If you use the describe method, now it will show the max value of that particular column. This you must be seeing, if I'm correct.
yes sir,
This was C. But what it is computed, how it is computed? This max value is
it
computed
is
not the
computed
same.
using id
No, no, it is computed using Q3 plus
q3
1.5 times of
q3
IQR.
plus 1.5 iqr, right?
That's why the values are different. This value is different and this value is different.
Okay. So
Okay, this
sir,
is the maximum value
from the
available
box
inside.
plot,
Yeah,
if I
yeah, yeah. Mhm.
want to go to find the exact value of my max value,
No, actually,
so using
exact value.
box plot only, and you're not using
Exact
numpy.
no, no, exactly it will be tough because you want exact to be it will be somehow around 1.0.9 or something you can take exact. I actually it is not possible right now. Can you see here? Otherwise, what you
Yes
can
sir.
do, you can put everything value. You can observe that that's not a problem. But if you put, remember we discussed how to put a values labels on a particular column on a particular chart everywhere. We
Yes sir.
discussed, remember? So you can plot everywhere, and when then you will plot here, you will see everywhere what is the value corresponding available. Okay, you can mention where you want to see the values. Okay, so you mention 0, 0.5, 1.0, 1.15, 0, you can mention after this 0.19 also I want to see, 0.18 I want to see. So it will automatically come across what is the value I am obtaining here. From that you can obtain corresponding value because that at that
Okay.
time the value will be coming here. So from that you can notify. Okay, you have to put the labels. But remember, these two are different things, right? Don't get confused with this. I think I got it, your idea. You get confused with this and this.
Yes sir. That's
Uh,
what my confusion was.
that is a column's maximum value, and this is the maximum value given by the outliers. And remember, I also, oh, sorry, by giving the box chart, I also told you, it's not that always you should remove the outliers. Sometimes outliers may be important for you, even.
Yes sir.
Okay, so don't always remove the outliers. So always go see data, how many outliers are there. Suppose in data set 700 are outliers only out of 800. Then will you remove the outliers? What will remain then?
Yeah, that was also my next
Uh,
question after that. That we are
uh,
having a number of outliers here. So shall we
then
remove
then
it or not?
then no no that please check what is the requirement accordingly. Suppose you have 1 lakh rows. Okay, in 1 lakh 5,000 are outliers. That is fine. At least 95% data is still with you, right?
Right.
So always see and accordingly act upon. I told you as well. There is not any hardcore rule that you have to do this thing only. Something works with our knowledge as well. What is my requirement? According to that, I will act upon.
Yes
Okay.
sir.
So I'll advise you one thing. I'm giving you one task. Okay. Take this Titanic data set you have, everyone.
Yes sir.
Okay.
We have.
Try to implement same algorithm using Titanic data set.
Okay.
Exactly same. Everything has to be same. Everything. That is very, very simple. Even more simple. See, if I import from, sorry, df1 is equal to pd dot read underscore csv titanic.csv. It is very simple even. I think only one df1 dot head. Only two numeric columns are there. Okay. So what is my output column this time? Survive column. Remember that. Okay. This is my output column. We have to predict whether the person will survive or not. Okay. And rest see, very simple data set it is. We have one nominal column, male and female, that you will be able to do easily using get dummies, right? Everyone. Very simple. And this is no
Yes
means.
sir.
Everyone may have a different name. So we will not carry this claim. So you have to drop this column. Makes no sense. Name can never help you out in predicting the model because everyone is having different names, everyone, right or wrong? So everywhere
Right.
we will have a unique value. So you will drop this column, just one text column will be remaining, this only column. Accordingly, encode that into a dummy encoding. And now everything is ready for you. Do the scaling. Once scaling step is required, okay. After that, just done with it. I really think it will take me maximum 5 minutes, not more than that. Correct?
Yes sir.
Please go through this, okay? Okay, everyone. So I'm ending for the day. Bye bye. It was
Yeah,
too
bye, sir.
long.
Thank you, sir.
Sorry for taking your time, but actually it was important. We have been doing that for the last 3 days, but actually this was important that I explained slowly as well, so that you get complete understanding how it is working. That is actually important. Okay.
Yes, sir.
And
That
see,
makes sense.
we have been doing this the same thing for the 3 days, right? 3 days we have been doing the same thing. Okay, you can assume that's how much time machine learning model takes to build. But now you will not take time. Okay, once you understand what is the process, I'll advise you go through that every means today itself. I'll share you this file. Okay, go through that.
Okay, sir.
Okay, bye bye.